Hello, this is Diogo, and on this video I will be solving exercises 3, 4e, 5c, 6b, 7a, and 8 of the second cycle of our ongoing. This video will use basically no editing except for this voiceover and some jump cuts so I can graph lines. Have fun! So exercise number 3. So first we're gonna solve 3a, which is the slope of AB. AB is going to be this segment here. So to find the slope of AB, we gotta find the rise over run of this line. So first we find the rise. So y coordinate minus y coordinate, 3 minus 1 equals 2, and then x coordinate minus x coordinate, 0 minus 5, it's going to be 5. So the slope is 2 over 5, which is rise of 2 and run of 5. Then slope of segment BC, here and here. So we're gonna do the same thing. So this and this, so negative 2 minus 3, right? And which is going to be negative 5. And x coordinate minus x coordinate, 2 minus 0, it's just 2. So this is negative 5 over 2. So slope of AC, this and this. So negative 2 minus 1, negative 3, the y coordinates, then x coordinates, 2 minus 5, because minus 5, I did this before, but negative with negative is positive. So this is going to be 7. So negative 3 over 7. And then D, which is the only one that's left on number 3, which is explain why a triangle ABC, which is this, is a right triangle. And we can see that it's a right triangle because segment AB and segment BC form a right angle. And we can see that because they're perpendicular to each other. This can be proven by seeing that their slopes, the AB and BC, are inverse and negative of each other. So that means they're perpendicular, which means this forms a right angle, which means this is a right triangle. Exercise 3 done. Okay, so exercise 4e, write the slope-intercept form of the equation. So this is the line, right, that we have. Then we need to write the slope of this. It's not as pretty as the real one, which should be there, but in the real one you can see there's a dot here and the 1, negative 1. So how I started to do this, I just did the point slope form and then I changed it into the slope intercept form. So the point slope form is y minus the y coordinate, which is negative 1. So negative 1 is going to be plus 1 equals to the slope, which, as if you look here, there's another point on the 4, 3, which means that the slope goes up by 4 and to the side by 3, which means that the slope is 4 over 3. So 4 over 3, and then parentheses x minus the x coordinate, as the x coordinate of this point here is 1, it's just going to be minus 1. So then we start changes. First let's mess with this x, right? So because distribution, oh sorry, my paper, minus 4 over 3, and this we can move to this side as a negative, so minus 1, and so this is going to be y equals to 4 over 3 x, which is going to be normal, minus 3 times 1 times 3 is going to be 3, 4 plus 3 is going to be 7, so minus 7 over 3, and that's it. So if you look here, 7 over 3 is going to be kind of the y-intercept, which is here, it's more detailed, and the slope, it's this. So yeah, for E done. Okay, exercise 5c, graph the line. This is the equation of the line, y equals 1 over 5x minus 4. So here I drew this graph with more detail than the other ones. I used the ruler to measure out the distances, so let's start. First, how I like to do this is I get 2 points and I draw a line over them. So -4 is the y-intercept, so 1, 2, 3, 4. This is one of the points, okay? And the other point, as the slope is 1/5, we know that it's raised over 1, so 1, 1, 2, 3, 4, 5 here. And then we pass the ruler over it, just a second. Before I pass the ruler, I actually like to find a second point, just to be a third point, just to be sure of everything. So, oh, sorry, camera unfocused. So just find the second point, we just do everything reverse. So go down by 1, and 1, 2, 3, 4, 5. So it would be around here. Wait, no, here. Right? Yeah. Because 1, 2, 3, 4, 5. Oh, this isn't focusing a lot. So it's about here exactly. And it went down by 1. So let me just graph this. I'm holding the phone with one hand, so I do need both hands. So I'm just gonna pause this for a second. So just to be sure of everything, I just did this and this to find the exact coordinate, and this to find the exact coordinate. And then, just to be sure it could be seen very well, I used the Sharpie to mark the line. And here, this is the line that's represented by this equation. 5C, done. Okay, so exercise 6B. State whether the lines are parallel, perpendicular, or neither. So the equations are, 3x equals to y plus 7 and x plus 3y equals 4. So let's start with this one because it's the easiest one. So we just check this in there. So y is equal to 3x, which it's normal, just change the order. And this was plus 7, it's going to become -7. So this is already one of the equations. Now I'm turning it into slope-intercept forms because I think it's easier to analyze it that way. So let's do this one. Let me just do a division here. So I'm checking the x to the other side. 3y equals to -x plus 4. Okay, so we're gonna pass the 3 as a division because it's a multiplication. So y is equal to so this is -1/1. It's going to be -1/3 x plus 4 divided by 3. It was actually -1, so -1 divided by 3, it's represented like this. Okay, so these are the full equations. So as you can see, here I'm using the slope to identify it, and as you can see, the slopes are inverse and negatives of each other, because one is 3/1, and one is -1/3. So you inverse it, and it's negatives, which means it's perpendicular. So these two lines are perpendicular to each other. Right angle. Boop. 6B, done. Okay, so exercise 7A, we have to find a line that's perpendicular to this equation and that passes through these points and then graph them. So first I want to make this equation more understandable. So 5y, then I'm going to throw the 2x to the other side. It's going to become -2x minus 3. So then I'm gonna divide by 5, the other side by 5, I mean both the sides by 5, right? So -2/5, because it's divided by 5x, and -3/5, because it's also divided by 5. So this is one of the lines. Then let's find the second one. How do we find it? I like working with the point slope form, so let's do it. Y minus the y coordinate, which is -3, so it's going to be plus, because negative and negative is plus, so just a second, I messed this up, plus 3, equals to, then the slope. As it's perpendicular, the slope has to be inverse and negative to the other one, so it's going to be 5/2. 5/2, parentheses x, minus the x-coordinate, which is 2. So this is the other equation. Now to graph it. To graph this one, it's really easy. You just come here, right, and go up by 5. 1, 2, 3, 4, 5, and go 2 to the side. 1, 2, bam. We found a second point to this line, to the perpendicular line, not to this one. So I'm gonna graph this real quick, just a second. Actually, before I do that, I'm just gonna find a second line, just to be sure I have everything right. So 1, 2, 3, 4, 5. 1, 2. This is going to be the second point. Be right back. Okay, so now to find the this line here of this equation. So this is our y-intercept, right? So this would be one of our points, but I don't really like working with decimals. It's pretty messy for me. So I'm just gonna find a concrete point. So what I'm gonna do is -3/5. I'm gonna add this, and it works. I've checked this strategy before. It's gonna be -5/5. So -1. So one of the points is gonna be here. The strategy works. You just add the intercept with this, and it works. But I've done it with just the decimals, and it turns out in the same spot. So this works, I promise. So I don't know if it's a valuable strategy, but I figured it out on my own. So yeah. Then we use the slope to find a second point. So -2/5. So we're gonna go down by 2. 1, 2/5. 1, 2, 3, 4, 5. Just to make sure I'm in the right spot. I think it's exactly here. And let's try it here as well. 1, 2. 1, 2, 3, 4, 5. And here it is. I'm just gonna do this line here, and just give me a second. Okay, so I was trembling a bit, so when I did the point, so I just redid this strategy here to make sure. And I marked over both of the lines. So as you can see, this forms a right angle, which means it's perpendicular, and this line is this line here, but it's as you can see, the intercept's here, and this line is this line here, and it passes through the given point, which is here. So yeah, 7A done. Okay, so for exercise 8, we have to find the perpendicular bisector of the segment MN. So MN has these coordinates. M is this and N is this. So first, let's start by graphing MN. So M is going to be -3, 4. So 1, 2, 3, 4. -3 is going to be about here. I don't need to have it perfect because I'm going to align it later. And N is going to be 5. 1, 2, 3, 4, 5. And 2. No, wait, 2 here. Almost messed that up. And yeah, I'm going to just join these. Be right back. Okay, so I just labeled the points and did this. I corrected the coordinates and made the segment. So now we have to find where the bisector is going to be at. So first, let's find its coordinates. To find the coordinates of a perpendicular bisector, we gotta do this. This plus the other one, which is -3. This is going to be just 2. And then, after adding the x-coordinates, we divide it by 2. So 2/2, it's going to be 1. So this is the x-coordinate. Then we do the same for the other one. 2 plus 4 equals to 6. And then 6 divided by 2 is 3. So the coordinates of where it's going to bisect are 1 and 3. So not 1 and 3, it's 1, 3. So now that we know this, we have to figure out the slope of this. So as you can see, the M is at -3 and 4, and N is at 5, 2. So we can see that this goes to the side by 8, because 5 5 minus minus 3 is going to be 8, and that's how you find the slope, right? So 5 minus minus 3, and 2 minus 4 is going to be negative 4. As it's rise over 1, it's going to be negative 2 over 8, which can be also translated into negative 1 over 4. So this is the slope of this. It goes down by 1. Oh, sorry, it's out of focus. It goes down by 1 and 1, 2, 3, 4. 1, 1, 2, 3, 4. I figured this out by, I already showed this, but I just, this minus this, and this minus this. So, okay, now that we have a point and a slope, we can do this slope form. So, y minus the y-coordinate, minus 3, equals to the slope. As it's a perpendicular bisector, this is going to need to be reversed to negative. So what's the reverse to negative of 1 over 4? 4 over 1, otherwise known as 4. So 4 parentheses x, so this here's the slope, right? And minus the x coordinate, which is 1, so this here's the equation. Let's plot it in the graph. So 1, right? This is where, oh, sorry, my paper. This is where it meets. So 1 and 3, so 1, 2, 3. This is going to be exactly where it meets. And then we just use the slope to figure out the other points. So 1, 2, 3, 4, and 1. So it's gonna cross here. Let's find out another one. 1, 2, oh wait, sorry. 1, 2, 3, 4, and 1 here. So this is a line here, and I'm just gonna plot this in the graph. So here you go. This is the perpendicular bisector. This is the segment. So here's the segment, and here's the perpendicular bisector. It bisects right in the middle, and it's a reverse and negative slope, and it passes through this point, which is where it bisects at. So yeah, that's exercise 8 done, and I'm done.